Okay, our learning goal today states that we are going to identify and graph perpendicular lines. That's what we're going to do on the front side here. So that's what's happening up here, what I just had you reading. And I already had you do this. Two lines are perpendicular if they intersect to form right angles. But now we have to consider what's going to make those lines, first of all, intersect, and then what's going to make them form right angles. Okay, so the lines will always intersect if their slopes are not the same. Because what did we learn earlier? What's the other thing we learned in this lesson in lesson 4.9? What kind of lines do we have when they have the same slopes? Parallel. We've just been working with it for what, about 3-4 days? We have parallel lines when they have the same slopes. They do have to have different y-intercepts so that they're different lines, but if they have the same slope, and then they do have those different y-intercepts, they're never going to cross each other. But as soon as their slopes are different, it does not matter what they are, as long as they're not the same. As soon as you have slopes that are different, those lines are going to intersect. But perpendicular lines are special kinds of intersecting lines. They not only intersect, but where they intersect, they have to form right angles. So here's what happens. This is huge right here. So if you circled one, box the other. I kind of circled one, so here's what makes that happen. If the slopes have opposite signs, so in other words, one of them has a positive slope, the other one has a negative slope, and are reciprocals of each other. Give me an example of some reciprocals. 2 and negative 2 are opposites. Seth, what was yours? Where were you modeling? I couldn't quite make out. 2 and 1/2. 2 and 1/2 are reciprocals. What was yours, Andrea? 3/2. And then what? Don't mumble. Let me hear it. 3/2 and what would be the reciprocal of 3/2? 2/3. 2/3. Okay, so reciprocals, and not only do they have to be reciprocals of each other, but one has to be positive and the other has to be negative. That's what it's telling us. Does it say anything about the y-intercept in that? Does it say they have to have a different y-intercept for this perpendicular condition? Read for me, tell me, does it say anywhere that they have to have a different y-intercept? What? No. The only thing we have to worry about are their slopes. We're going to pay attention to their slopes only. They have to have opposite signs and they have to be reciprocals of each other. So, which two equations in this one? They decided that y equals this one right here, y equals -1/3 x plus 3, and the y equals 3x plus 2. They decided those are the two lines that should intersect and form right angles on the graph because 3 and the 1/3 part, those are reciprocals. And then the 3 is positive and the 1/3 is negative. So they are opposite signs. That's what creates the perpendicular lines. So let's go down and practice a couple of these. Identify which two lines are perpendicular, then graph the perpendicular lines. Let's do this. It's kind of hard to tell how many equations we have here. So wherever there's a semicolon, there's a new equation going to be written. So there's one. Here's another equation. So it looks like we have 3 of them. Okay, today we only have to identify for this part right here, we only have to worry about their slopes. So what's the slope of our first equation? -2/3. What's the slope of our second equation? 3/2. The last one's a -2/3?
Wait, no,
Positive 2/3. Okay. So again, for this part right now, for us to decide which ones are perpendicular, all we care about is what are their slopes. Okay, so first of all, what's one of the things they have to be? Reciprocals. That's the first thing I would always look at. Do we have any reciprocals going on here?
Yes. The 3/2 and 2/3.
Yeah, 3/2 halves and 2/3 are reciprocals of each other, aren't they? So we have reciprocals, but what's the other condition it has to meet? Not only are they reciprocals of each other, the slopes, but they also are opposite signs. Opposite signs. So the 3/2 can be combined with either of these 2/3, but you know what? It's a positive 3/2, so it has to go with the which one? The negative 2/3. So we're going to circle those two are, we're going to say these are opposite reciprocals. Okay, well if they are opposite reciprocals, then we're convinced that those two equations are equations of perpendicular lines. So what we're going to do is that right here we're going to write that we have y equals negative 2/3 x plus, did my circle over it? What does it say? 2. Okay. And y equals negative, or not negative 3/2, it's a positive 3/2. 3/2 x plus 1 are perpendicular. And I'm going to show you what the mathematical symbol is for that, but I want you to write it one time here, okay? It's kind of a long word, but there's a mathematical symbol for it. Anybody know what it is? My first name starts with a T. It's an upside down capital T. So we just flip it over. It's an upside down capital T. So you can put here, that shows perpendicular. It's a lot faster than writing out the word, isn't it? So now we're going to go prove it on our graph. Okay? So we're going to graph just those two. So now what would be helpful is if we knew what the B was for this one and this one. What's our B for the first one? 2. Okay? Let's go get that one graphed. Now, it is important that you do these one at a time. Draw the line before you do the other one because you're going to have points kind of randomly. They're not going to line up in these nice parallel patterns anymore now when they're perpendicular. So let's graph this one. Starts at 2, has a negative 2/3 slope, so we need to go down 2 to the right 3. Or what's our other option? Up 2, left 3. And take your ruler right now and draw that line. Do not move on to the other one until you've drawn this line. And then ask yourself, is the behavior of that line what I expect it should be? It's falling. It has a negative slope. All seems well, right? And now we'll go over to our other equation and get it ready to graph. What's our B value? 1. Okay, so on the graph, we'll go put a point at 1. And it says a slope of 3/2, so we can go up 3, right 2. We can go down 3, left 2. It has a positive slope. It should be rising from left to right. On this assignment, one line should always be rising, the other one should be falling. I want you to find another piece of paper that you have somewhere that you can grab. Because here's how you're going to check to see if you have perpendicular lines. You can eyeball it. That's one thing. But then we're also, I want you to take a piece of paper and in the corner of it, if you stick the corner of your piece of paper in the angle, the edges of the paper should line up along those two lines. If you have a right angle, because the corners of your paper are right angles. So if you take the corner of your paper and put it in the corner of the angle, you should end up with, need that out of there. You should end up with being able to tell if it's a right angle or not. Okay? No, That's not what I want either. How would I get that on? No, I think which one? This one? Should I just go? There you go. Good job. Such a big teacher. Okay. So let's go to, well, I thought we had it back to normal here. Okay, I want you to move on to the next one. I want you to draw those lines down showing where you have your equations so that they're easy to identify first of all. Let's see what it did. It moved my tools to the bottom. I want them at the top. There we go. Okay. How many equations do we have? 3. What do we need to identify from each of them? What do we need to identify from each of them? It's just the slope right now. What's the reciprocal of 2? No, I'm asking you this question. What is the reciprocal of 2? 1/2, right? Because 2 can be put over 1 and then we flip it and its reciprocal is 1/2. Because since 2 is positive, what would the other 1/2 to be? A negative 1/2. So our 2 that work this time are these 2, aren't they? A positive 2 and a negative 1/2. They're reciprocals of each other. One is positive, the other is negative. So we're going to, first of all, we're going to go down here and we're going to write y equals 2x plus 2 and y equals negative 1/2 x plus 2 are upside down capital T, right? Perpendicular. And now we just need to graph to verify. So we just need the b values for those 2 to help us graph them. The b values don't matter for the deciding perpendicular or not, just for graphing. So go ahead and get both of these graphed because you know how. Hey, notice something about what's true about their y-intercepts. They're the same. So this will help us prove whether or not you can have perpendicular lines that do share the same y-intercept. Remember what I said about making bunches of points? When we're doing perpendicular especially, it's kind of nice to have as many points as you can. Right, Blake? Yeah. Okay. Thanks for agreeing. And what's your last check going to be after you get your lines drawn? You guys should use the corner of, you can use the corner of the ruler too, or a piece of paper, something to check out, see if you got right angles. Or I can give you a protractor and we can measure them that way. But the corner of the paper is pretty handy. Yeah, down 1/2. But it's a really quick question I also want to ask you. It's some critical thinking here. Do all intersecting lines have to have one be a positive slope and the other be a negative slope? Intersecting lines. Okay. Because remember, what did I say? All lines will intersect if they what? Just have, what do they have to have? That's different. easily supports for us that they don't have to have different y-intercepts. They only have to have the other condition with the slopes, opposite reciprocals. They're opposite signs and reciprocals of each other. Okay, anybody have any questions on this learning goal? This part of what you'll be doing in the homework. Okay, let's go to the back side where the other learning goal will be addressed. I can find the equation of a line. So we have this, remember, finding the equation of a new line. This time it's going to be, our new line is going to be perpendicular to the given line, and it has to go through a certain point. So in this one, we have, write an equation in slope-intercept form for the line that passes through ordered pair 2, 5, and is perpendicular to y equals 2/3 x plus 2. So this is our given line. I already know that's a line that's going to be rising from left to right, right? Because it has a positive slope. Has to go through this point. But, so I already know right now, for them to be able to be perpendicular, what has to be true about that other equation slope? It has to be positive or negative? It has to be negative. The new line has to have a negative slope. So, here's what they're doing in step 1. We find the slope of the given line, and we then that helps us decide what is going to be the slope of the perpendicular line. The reciprocal of 2/3 is 3/2, and the opposite of a positive is a negative. Then notice what they did here in step 2. Say, okay, here's our new line. This is the new line, okay? New line. I want you to put this in your notes. So here we were working with the given line. Now in step 2, we're working with the new line. The new line has to have this slope. It has to go through that point. Notice what we're using, point slope form. Substituting into it. And then in step 3, getting that put into slope-intercept form. And we have our equation of our new line. This is our new line. Put this in your notes. And this one isn't actually graphed. And when we do the one that we're going to practice together and in the homework, we will graph it to verify it. Okay? So let's look at number 3. Write an equation in slope-intercept form for the line that passes through 8, -1 and is perpendicular to the given line y equals -4x minus 7. So let's do this right here. Let's put step 1. In step 1, we are working with the given line. Y equals -4x minus 7. What do we need from that given line?
The slope in b value.
Do we need the b value right now?
No.
What do we just need the slope, don't we? So m equals -4. Not the x, just -4. Which means then that the new line has to have a slope of what? First of all, this is negative, so it has to be, this one's negative, so this one has to be positive. The reciprocal of 4 is 1/4. So the new line has to have a slope of 1/4. Then we'll come over here and we'll combine steps 2 and 3, because in reality, one just flows into the other. We are working with the new line. Okay, so write that here. So we know it has to have a slope of 1/4. We know it has to go through what point? 8, -1. So we are ready to do our into point slope form. We call this our x sub 1, y sub 1. And we'll substitute into point slope form. Even if you don't write this every time in your homework, let's have it in your notes right now, just so you have a good picture of what we were doing. Substitution step. Does this need cleaning up?
Yes.
Let's clean it up. So we have y plus 1 and x minus 8. But what do we do with that minus?
Plus a negative 8.
Yeah, we're going to kind of unclean it up for that part, okay? We're going to make it plus and minus so that when we multiply correctly. Okay, go ahead and finish this up. Let's see if you get the same equation I do. When you're finished with it, then you can look and see if you agree with me or if you have to help me fix mine because you're convinced I'm wrong. So the first thing in this is get the equation. Okay? So here's what we're going to do before we graph it though. We're going to come over here and underneath the graph we're going to write our two lines that we have. We have y equals negative 4x minus 7 and we have y equals our new one, 1/4 x minus 3. Because we need the m and the b for each of them to help us graph them. So graph one at a time. And when I say graph one at a time, that means draw the line and everything. Do not even think about moving on to the other one until you not only plotted the points, but also drawn a line through them. Hopefully you're starting to see it'll get really confusing if you do not take them one line at a time while you're graphing and actually draw that line and then ignore that line to get your other line graphed and then do the corner of your paper test to see if you have right angles. And what else do we have? One last thing to do on this one. What else do we have to do? It has to go through go through 8, negative 1. So we go to 8, negative 1, and we say, oh, there's that point right here. 8, -1, our new line passes through the point it was supposed to. Okay, any questions so far? Okay, on your worksheet, the front side is like the front side of the notes. You'll have 3 problems to do. The back side is like the back side of the notes. You'll have 2 problems to do. So until this, but you're not starting on this